This is our sixth and final video tutorial on polynomial inequalities. And here we have x cubed minus 3x squared minus 5x plus 15 smaller than 0. And we want to find the values of x that will satisfy this equation. So all the values of x that will make this expression negative or smaller than 0. And as explained in our previous videos, what we want to do is find critical values. And we find critical values by factorizing this expression. And for this example, we'll factorize this expression using grouping. So I'll group the first two terms together and the second pair of terms together. So the greatest common factor in the first two terms is x squared. And when I factor x squared, I have x minus 3 as my bracket. Now for my second set of terms, I want to create the bracket of x minus 3 as well. And in order to do that, I need to take out the greatest common factor of negative 5. So if I take out negative 5 times x, I'll have negative 5x. And negative 5 times negative 3 would be positive 15. Now I have two terms instead of 4. And I can identify the greatest common factor of x minus 3. So I take out x minus 3, and in the first term I'm left with x squared, and in the second term with negative 5. Now you would think I'm done factorizing, but I can still factorize x squared minus 5. And when I do that, I have x minus 3 times x minus the square root of 5 times x plus the square root of 5. And from here, I cannot take out any further factors, so I can find the critical values. So in order to find the critical values, I would set each of the brackets equal to 0. And that leads to x equal to 3, x equals to the square root of 5, and x equals to negative square root of 5. Now x equals to negative the square root of 5 is a valid answer. Notice that the negative is on the outside of the square root. Therefore, this value can exist on the number line. If it was square root of negative 5, that is not a real value and we cannot plot it on a number line. Our next step is to plot these values on the number line. So I have negative the square root of 5, then the square root of 5, and then 3. And the number line represents our x-axis. So now what we want to do is identify where on the number line would the expression be positive and negative. And in our previous videos, we substituted a value in the place of x after our last value in order to determine whether or not that's a positive or negative value. But for this video, I'm going to use x equals to 1. Because x equals to 1 is somewhere between the negative the square root of 5 and the square root of 5. So it will be 1 cubed minus 3 times 1 squared minus 5 times 1 plus 15. And that is equals to positive 8. So that tells me between the two square roots, the expression would be positive. Therefore, to the left and to the right of it, it would be negative. And then after 3, the expression would be positive again. And as explained in a previous video, you do not need to know how to plot the cubic function. What you want to do is interpret the expression by using the critical values on a number line. So we want to find where would x be smaller than 0. And we can see that for any value between the square root of 5 and 3, it will produce a negative value, meaning a value smaller than 0. And also for any value towards the left of the negative the square root of 5, that will also produce values that are smaller than 0. So this inequality is satisfied for x smaller than 3 and bigger than the square root of 5, and also for x smaller than negative square root of 5.